using MySQL? More than 10 years? So the rest of you less than 10 years? Really? More than 5 years? How many of you have been using MySQL more than 10 years? Okay. More than 15 years? More than 20 years? Oh, no, in your present life even, 20 years is not hard. This MySQL has been going on for a lot longer. Okay, how many of you have in recent times thought maybe you'd like to use some other database, be it Postgres, MongoDB, or something? Did you think about it because you didn't like the ecosystem? Or you thought Oracle was going to kill MySQL? No? Okay. Anyway, none of that is true. Oh, it's auto-playing.
No, I'm just oh. It's not auto-playing.
Okay, I was like, oh, we have a screen problem. So I will continue dancing till the technical difficulties are fixed. Okay. Yes. Let's start with the Q&A. I will repeat your questions. Since you're already MySQL users, anybody have a question about MySQL? No? What would be the next MySQL version? That's a very good question, right? It is currently 8, and they ship very interesting new features in every point release. What will be the next major release? Will it be 9, 10? Like MariaDB jumped to 11. In fact, it went from 5 to 10, and then 11. So there's lots of jumping. So what will be the next one? Who knows? Maybe they'll call it 2023. I don't know. Oh, we're here.
Yes. All right, let's get started because we're going to run out of time. Okay, I just want to thank everyone coming in today. And it's my first time in Singapore, first time in FOSSASIA. So thank you for inviting and hosting our session today with Colin and with his previous talks over here. This talk, I just want to remind, we've been actually handling this talk for almost 10 years with Colin and switching and sharing our experiences. So we'll start from the beginning, inception of MySQL. So some people know about where the MySQL came from, but I actually always try to have where this all started. So basically, Monty actually had an idea of writing this code, and actually started a long time ago. Now it's 28 years, and there's a little bit of a history about that. But where it ended up in Oracle, and that's where the background of the MySQL is.
Yeah, and to be clear, InnoDB is still very much the storage engine of choice, even though back then we called that InnoDB Friday. It was a very dark day for us at MySQL. We subsequently went out to acquire this storage engine called Falcon, which is now dead. And BDB was also part of Sleepycat. BDB as an engine doesn't exist any longer, but it was. So actually MySQL has evolved a lot in the last basically 3 decades.
Yes. So there are some stakeholders that we should know about MySQL. After the Monty's inception, there's in 2008, Percona actually took the fork of MySQL. As of today, it's still a live database and supported database that's based on MySQL. And there were some other distribution that didn't last long. But in Oracle actually holds both versions of community and the enterprise editions of MySQL as of today. Anything on this?
Oh yeah. So in theory, the Maria engine was always being developed. It was called the Maria. Now it's called Aria. It was renamed actually. So yeah, before acquisition, there was an idea that maybe the Maria engine needs to continue development, but the company actually only got started much later. Like actually in the summer in Mallorca of 2009 was when a bunch of us decided to go and set up a new company. Unfortunately, I didn't make the first meeting because I got the chicken pox.
So always something happens. Okay, so we want to fast forward because we haven't been doing this type of talk for the last 3 years. And we recently came back on the live events, and Colin actually presented in the last FOSDEM in February. So I'll let him actually run this one.
Yeah, so MySQL sold to Oracle for, to Sun for $1 billion. Sun sold to Oracle for, I don't know, 7 maybe. And MariaDB actually went public last December 19th. It's trading as MRDB. I'm sure if you go look for the stock price now, you'd probably laugh. It's a sad situation for whoever's still holding the bags, as they say in crypto. But this is actually on the stock exchange. A lot of rapid releases now is the plan with long-term support releases. So my advice to you is to actually use a long-term support release if you're going to deploy. Not actually deploy with rapid releases that you have to upgrade every year, because I don't think anyone in production does that. Percona has also rebranded. I think they're beyond just a logo. They've rebranded in general as a company and what they offer. So that's also very exciting. Oracle makes so many amazing changes into small releases of MySQL. You consider them minor releases, but they're actually all major. They include nice new bugs and nice new features. So it's a huge bonus. I highly recommend you read the release notes carefully. Amazon RDS ditched DRBD for semi-synchronous replication. So it's actually much faster if you use multi-AZ. Anybody here use Amazon RDS? Okay, so if you're using RDS, you will actually notice much more speed improvements for inserts, for example. While Amazon finally migrated to semi-synchronous replication, Facebook decided we'll go one step further. We'll actually do something called RAF-based replication. And they've actually got RAF protocol built inside as a replication layer. So actually now there are 4 types of replication in the MySQL world: asynchronous, semi-synchronous, virtually fully synchronous, and RAF-based. Except if you want to try the RAF stuff, you have to compile software from the Facebook tree, which I'm sure many of you here at FOSSASIA can do.
So after that, fast forwarding the 3 years, the latest news started coming out. And this is a very latest update from the MySQL versioning, which was announced in the MySQL Summit, like in Japan, maybe a month ago. And they started getting into long-term release support. The reason is they are going to be staying in version 8 for a while. And version 8, as Colin mentioned, minor versions are actually happening as like a major feature changes. And we'll talk about that a little bit later, but this is the latest long-term support that will allow MySQL to continue on this version. Anything on this?
No, I think it's really important to just focus on support lifecycle.
Yes, support lifecycle. Okay, this is a nice graph that we like to share that Daniel actually put together. It's in GitHub. There's a link over here, and actually this poses of where the MySQL came from. There's also a little earlier graph that we removed, version 3 and etc. So that's the branching tree, how it's being actually handled until today. So we are actually going through that cycle of events, and as you can see, MariaDB is going through the minor versions of 10, and right now it's in 1.6. Anything on MariaDB?
Yeah, like rapid releases, right? So you're actually getting several a year. So pick the LTSs. I mean, play with the short-term releases because they've got nice new features, but pick the LTSs.
Okay, so this actually is a good sign that both MariaDB and MySQL versions are being deployed in new versions and the features being added. That actually adds to the community having new features. So important update over here in 5.7, if anyone is actually using 5.7. Anyone in 5.7? Some customers? There'll be some customers always. End of life is in October this year, so there will be no official support unless there's a special case. As of today, this is the date that MySQL Oracle will no longer be supporting. So there's a lot of things going on, but maybe you want to look up some of the other presentations we've done in the past. There's one from me. I've done a bunch of runs in 2019 for the upgrade in MySQL. to get everyone prepared for the next 3 years. But apparently there are still people using 5.7, but it is time to upgrade. So anything on the new features? Okay, I can just run the MySQL 8. It covers both database administration and development features. From the database side, there are major changes in 8 compared to 5.7, including security and the native data dictionary. Some of the performance improvements were bound to the original structure of MySQL. So those are being basically changed and rewritten to get more optimization in the database. There's also on the software development side, there's a bunch of things which highlights of getting the developers more embedded into MySQL. MySQL shell is one of them, and the JSON support is the other one. And let's quickly switch to that, and MariaDB.
Yeah, and MariaDB has actually got lots of those features that MySQL has, but also can maybe delve out of what MySQL can support, right? So an Oracle PL SQL layer, so you can migrate most Oracle apps to MariaDB is, of course, something that you'd never see MySQL do, probably. Things like DML only, flashback, many interesting things. So dynamic columns is also, I'd say, unique. Actually, I try to keep this slide to only unique things that you'd find in MariaDB. Proxy protocol support is maybe not so unique because Percona server has it, but standard MySQL doesn't. So slides will be available, of course, so do check them out.
We will upload the slides, so we will have all that. Fast forwarding to MySQL 8 releases. So we have actually talked about the 5.7 to 8 and the bug fixes and all that. All the minor versions of MySQL actually now includes a new features, and it's actually like a new version. And the latest one, as of March, included these two big changes with DB replica set, cluster and cluster sets. That was presented recently by Oracle, and I'm sure there's some talks about that. Also, another feature that's important, instant add drop. This is an important operational issue that if you have large keys or columns to add or drop, that might be operationally difficult to handle in some cases on active systems. So check this out. Right now, it was introduced in 31, but in 32, it is recommended they found some issues. It is recommended to only run on 32. So you have to be on the latest and the greatest release of MySQL. Anything on 8.0?
Yeah, so you'll find bugs even in point releases. And this is maybe one of the biggest changes you'd see in MySQL 8 is to actually pay attention to point releases, release notes. Important update on that. Percona is also following this trend of getting these updates. Percona server is actually following the minor versions slightly later than the Oracle. This one of the major reasons, if Colin agrees, is the backup. Extra backup only works on the latest version of MySQL that Percona releases. So if you are on open source and using extra backup as the backup utility, you actually need to be following the Percona server to be releasing the latest support for that version. And that's how the... Yeah, it's because extra backup is tied to the InnoDB version, which is why actually Maria backup exists now as well, because MariaDB forked extra backup for that sole purpose.
Okay. That's a good highlight. And so there's a bunch of updates on the Percona server that's also coming out and following, which is in addition to MySQL, Oracle MySQL's Community Edition. So we get some of these features. Some of them includes the storage engines and Vault and stuff like that, so you can check those out. There's an advantage of using Percona's open source version versus the community edition that Oracle provides. I think one thing that we haven't mentioned over here is these minor versions of MySQL is one way, so there's no rolling back to the previous version. And Colin will say something about that.
It's true. It's actually a problem. So if you're planning your upgrades, know that downgrades are hard. So take backups. Yeah. This is a little bit different in the MariaDB world, where forward and backward compatibility is actually still kind of primed.
Yeah, so this is important reminder. Anyone is thinking of upgrading, you need to plan how you actually circle back into the old version or failover. If your data set is large, if your transactions are high, this is a difficult task that you need to handle properly. Okay. So there is something that we've compiled in the past, comparing the Enterprise Edition versus Percona Server versus the Community Edition. So these are the updates that the Percona Server provides. You don't need to pay for the Enterprise Edition, but you can actually still use the Percona Server to get some of the features if you're using. And there are some things to check out. Okay. All right.
So MyRocks is a nice little storage engine built on top of RocksDB, basically developed by Facebook. In fact, Facebook is mostly running on MyRocks now. They've migrated nearly their entire fleet to MySQL 8 with MyRocks and this Raft replication layer. So the reason for them is it's because it's much better from a compression standpoint. So compressed InnoDB is not as efficient or space efficient. And they also want write efficiency. So in terms of translation, this is hardware savings for you, right? And it turns out that if you are in the cloud, for already fairly long time, MyRocks has been enabled in the MariaDB distribution of Amazon RDS. So maybe it's a bit of an underrated feature of MariaDB, but it's an engine that probably could use a lot more marketing. Besides the fact that, Facebook's migrated to it and on nearly its entire fleet. So I think both Percona and MariaDB probably need to spend a bit more time on it. Next slide, I guess.
And then this is how the MyRocks actually handles, like Colin said, it's mostly hardware and the storage savings. It helps on the compaction and the compression of the data, and that's where what from our friends at Facebook saying that they were running out of space because of the data that's being used, and this helped them save storage, and the storage needs planning in advance. Okay, so popularity on MySQL is going very high, still strong in the community. We're still number 2, and considering Oracle, I don't know if it's like a Oracle. MySQL is not just Oracle, so that's the ranking. Okay.
MariaDB, I think, is number 11 or 12.
And this jump is the Snowflake, by the way. So that's an interesting highlight. That's how the Snowflake actually made that jump over there. Okay, some talks about the proxy and proxies.
Yeah, I expect that if you run at scale, you probably will end up needing to use some kind of proxy, be it HA proxy, proxy SQL, router. MySQL router is actually default configuration literally for your InnoDB clusters. Proxy SQL or HA proxy for your Percona HDB clusters or your Galera clusters. And then, of course, MariaDB also ships something called MaxScale. But that's under a business source license, so not as popular as you'd expect, because you got to pay for the service behind it. But it's a good proxy, just badly licensed.
So the long story short, use a proxy if you're using MySQL. So that's basically the best practice, to put a proxy in front of a MySQL servers. And there's a lot of talks and a lot of content blogs about this. If you haven't heard about any proxy, check those out. And we talked about the proxy SQL is the most popular and common proxy for MySQL, and the MariaDB's MaxScale is competing product, which the later version is actually more licensed. And so the proxy vision is basically put proxy in front of your database server, take advantage of the read-write splitting and query routing and some other features that it has. Oracle has a similar proxy vision. Any words on this?
Yeah, so Oracle's router, similar vision. And the reason you get router, proxy SQL, and versus HA proxy is the fact that one's a level 7 proxy, understands SQL protocol, one's like level 4, just TCP IP. So a little different from that standpoint. Okay. Plenty of HA solutions out there today. We've already talked about the group replication in DB cluster. You've got Galera, of course. Go to a Galera talk. Clouds, plenty in the cloud. Maybe Vitess.
Yes, Vitess does support sharding. So we'll just go through the tooling. There's a bunch of tools available, open source tools that you can actually orchestrate your proxy MySQL ecosystem. And some of those are highly used in the day-to-day operations of, and one of that stands out is the Percona toolkit. If you haven't heard about it, please check it out. The trending topics will run very fast on this one. There's operators. Of course, in the Kubernetes world, we got a lot of operators, and the MySQL is leading. And there's a Vitess for sharding framework for MySQL, group replication Gorilla for HA solutions, and there's other bunch of tools and utilities that allows this ecosystem to be run. And I will go through real quick in the operators. There's known operators as Percona Kubernetes operators runs for the XtraDB cluster. So it allows to run a database in data on Kubernetes for stateful workloads. PressLabs has its own, and Vitess actually runs an operator. And also MySQL, Oracle MySQL operator came out within the realm of group replication to handle data on Kubernetes. And we can skip those, and we have a bunch of books available in the MySQL. And one of them is the one that I co-authored with Sveta. Tomorrow we will have a session about this, and hopefully have a book signing also. Thank you.
And speak to us as to why Percona is ditching proxy SQL for HA proxy in their Kubernetes operator. If you have any questions, it does say end, but we will be outside.
Sorry everyone for the short delay. We faced some technical difficulties, and who are joining here in from YouTube or in live stream from China or friends from China and all. Sorry about that. So our next session, we have an distinguished speaker. It is Hernando Vicaxano. He works in Oracle. He will be talking about MySQL InnoDB cluster set, concepts and architecture for disaster recovery solution. Over to you, sir.
Thank you. Good morning, everyone. And apologize for technical issue that I encountered just now. I hope that I can finish this talk on time. Yeah? So I wanted to introduce myself. My name is Sananto. I am, as you see, and my logo is an Oracle employee. So I'm Oracle MySQL Principal Solution Engineer. And today I would like to share with you a little bit details about InnoDB cluster set. As the name indicates, the InnoDB cluster set is set of InnoDB clusters. So the expectation here is you have a couple of InnoDB clusters, more than one InnoDB clusters running on multiple sites. And cluster set basically is standardized technology on how we can do data synchronizations between InnoDB clusters that's running on multiple sites. And this is for disaster recovery solutions. Why we do this? Because we realized that organization face a big challenge, especially if there is a major outage on primary data center, and it can cost them a lot. Okay, based on survey, okay, it is more than half saying that they experience an outage costing more than 100,000 US dollars. And most of the time, they say that on-site power failures is the biggest cause of significant outage. And in a data center, there are a lot of important stuff over there. We have servers, we have firewalls, we have database applications. Everything is mission critical, okay? And power is just one of it, okay? Power is not everything in that case, but everything is nothing without powers. If you lost powers in data center, that's it. So to mitigate this, then we need to have, business need to have alternate sites and running duplicate of the system, on the alternate site and do database synchronizations. And as you see, we have MySQL asynchronous replications. It's very simple. Okay, it has been around a long time back. We have source, we have replicas. Every time we make transaction and commit it on the source, then winlock event will be sent over to the replicas, and the replicas threads will actually capture the data and then commit the same data to the storage engine, so that the expectation is we have source and replicas running and data will be consistent, but it's not always true. And in the past, okay, DBA have a lot of job, especially if they want to deploy replicas, okay. Primary and secondary, source is where the transactions happenings, and replicas is where the transaction is getting replicated. And we have a new terms called primary and secondary. Okay, primary is read-write, secondary is read-only. And a lot of jobs that the DBA need to be done by the DBA in the past. They need to do backup of database, and then they need to transfer the backup from the primary side to the alternate side. They need to restore the backup to create a secondary database, and starting up in read-only mode. And they need to create replication users on primary database and assign replication slave privilege to the replication users. And they need to go to the secondary database, connect to the secondary database, and create the replication channels. All this need to be done manually, and it's not a complete solution if you are talking about disaster recovery solutions, because disaster recovery means that we need to orchestrate as well, right? If the outage happens, then we need to make sure that human interventions will be minimum. Okay, everything should be standardized. Okay, then there are a lot of workarounds need to be done in the past. Let's say doing a custom script, for example, for DR orchestrations, or incorporate third-party tools. Okay, just in case if DR activation is happening, then they can use this third-party tool to orchestrate the disaster recovery procedures. But now we have InnoDB clusters. Okay, InnoDB clusters is based on group applications, as you see. It's still using asynchronous replication underneath. Okay, however, we use group applications protocols basically to make sure that this asynchronous replication become really synchronous. Yeah, data will be consistent across the InnoDB clusters members. Okay, we have primary and multiple secondary. Okay, it is read scalables. Yeah, primary will run on read-write mode, and secondary will run on read-only. And we have MySQL routers, as explained by the previous presenter. Okay, MySQL router is our default component in InnoDB clusters to provide connection transparency to the application, so that the applications to connect to InnoDB cluster does not need to change. Okay, of course, this is layer 4 routers. Yeah, it's based on port number. Yeah, there are two kinds of port numbers. First is read-write port, and second is read-only port. So application will see MySQL routers as database endpoint, so they can connect to the MySQL routers. If application connect to the read-write port, then MySQL router will redirect the connections to the primary. If the application connected to read-only port, then it will redirect the connections to the secondary nodes. And we have integration as well with MySQL Shell. Okay, MySQL Shell has admin API that enable DBA to deploy this InnoDB cluster easily. Okay, you don't have to take a quite long time actually to pick up how to deploy InnoDB clusters. It's very easy. You can deploy 3-node InnoDB cluster within less than 5 minutes if you talk about standard default InnoDB cluster installations. Okay. Okay, this one is the differences between synchronous replications, normal asynchronous replication, and synchronization that happening in the group replication that used by InnoDB clusters. Every time there is a new transactions getting committed, then it needs a consensus. It needs quorum. Consensus happening when more than half or majority of the nodes within the group application itself, okay, certify the transactions. Then the transaction will get committed on all nodes. The result is InnoDB clusters can provide maximum data protections. Okay, whenever there is new transactions going into the routers, read-write on the read-write ports, then the routers will redirect that connections to primary nodes, and if there is any commit, then the binlock event will be sent over to all the secondaries, and certification process will happen. And upon quorum, okay, each members will commit the transaction to the InnoDB storage engine. There are a lot of models or types, okay, to control the consistency in InnoDB clusters. If you take a look over here, right, the time when the transaction is really getting committed on each node may not be the same on the same time, okay, because we are using consistency, eventual consistency as the default consistency in InnoDB cluster. However, if your application connected to the secondary node and require new data, then we can set the consistency to before. Okay, there are 4 consistency: before, after, eventual, and before and after. So this is pretty much application requirements. So the InnoDB clusters also provide automatic failovers. Whenever primary node is failing, then group applications will promote one of the nodes to become a new primary, and application does not need to change the connections because MySQL routers. Yeah, so because of MySQL routers. So MySQL routers will redirect the read-write connections to the new InnoDB cluster primary node. How about if the fail node comes back? Once the fail node comes back, then it will try to join back to the clusters. So we have auto-healing capability. Yeah. So once the nodes comes back, then it will try to catch up the transactions, to catch up the state by doing recovery. Okay, it can be used. It can use clone, or it can use incremental recovery, and group replication framework will automatically select which distributed recovery method, okay, suitable for recovering the failed nodes. And once it is completed, then the failed node will fully join to the InnoDB clusters as secondary node. And at that point in time, okay, the routers will start to see this secondary node. Yeah, so the failed node will be joined back as a secondary node. How about MySQL routers? We advise MySQL routers to be installed on, on the same host as the application, so that the application can connect to the local MySQL routers. Or, optionally, we can run MySQL routers outside the application servers, but you need to provide high availability of the MySQL routers. Yeah. You need to have more than one MySQL routers, and load balance will be, or high availability of the MySQL router will need to be provided by third party, let's say pacemakers or Keep Alive. And in 2020, we released InnoDB replica set. Okay, it's basically MySQL asynchronous replications with add-on integrations with MySQL shell. Okay, admin API. So creating the asynchronous replication is no longer completely manual process, but it is more automated and orchestrated using admin API. And secondly is integrations with MySQL routers. Okay, so using MySQL InnoDB replica set, we don't need to have VIP failover in it when master is failing or something like that. But we can use MySQL routers basically to redirect the connections from the applications. If application connected to the read-write port of the routers, if the primary node failed, then the primary node is available on the other nodes, then MySQL routers will redirect the new connections to the new primary node. But bear in mind, this InnoDB replica set does not have automatic failovers. Yeah, so we need to failover the primary node manually. So in order to make this even more suitable for disaster recovery solution, we have disaster tolerance solutions with MySQL InnoDB replica set. So what is a replica set? We have two or more InnoDB clusters with asynchronous replications to replicate data between primary of the primary clusters and second cluster. We call it as replica clusters because it is read-only clusters. Okay, replicate into the primary node of the replica clusters. Bear in mind that in this architecture, only one node, which is primary node of the primary cluster, will be running on read-write. The rest of the node will be running on read-only. Okay, the rest of the node will be running on read-only. Upon commit on the primary, okay, once the certification done, the transaction is committed on the primary, then data will be as replicated using asynchronous replication to the primary node of the replica clusters. And again, it has MySQL shell admin API so that you can install and configure in very, very easy way. Yeah, easy way. So if you have 3 data center, then you can actually extend, okay, each of data center will have its own InnoDB clusters, but only one become primary cluster and 2 are replica clusters. We don't have automatic failovers of the from the primary cluster to replica cluster, but I will tell you why later on. Okay, not every cluster has to be on 3 nodes. Okay, we can have one of the clusters, okay, have different topology. Let's say you only need to have replicas on disaster recovery, but you don't want to have a high availability. Okay, that's fine. You can have replica cluster only consists of one node, which is primary node that running on read only on your disaster recovery site. How about MySQL routers? MySQL routers can run on every site, every data center. Okay, and the application can transparently connect to the MySQL routers. Okay, if MySQL routers, if application connect to the MySQL routers in read-write ports, since MySQL router aware about the cluster set topology, the MySQL routers will connect this, reconnect the connections to the primary node of the primary clusters. So in underlying, even though in the database infrastructures we have a single clusters become a, is a read-write clusters, and then the rest are read-only clusters. But if you have requirements that require each site to be active, then you can use MySQL routers as database endpoint. Yeah, because MySQL routers can run on everywhere. Okay. So as you see over here, even though MySQL routers by default always looking for the primary clusters, okay, MySQL routers running on standby set can also connect to the primary clusters, but we can have, additionally, optionally, we can have MySQL routers running to connect only to the specific cluster within the InnoDB cluster set. So this is the MySQL InnoDB cluster set configuration. First of all, we need to create InnoDB cluster. As you see, it's very simple. Okay, dba.create cluster. Then you will have one InnoDB cluster with one node. And then you can just add instance, okay, to add the second node and to add the third node. You don't need to do a backup and recovery because it will do clone. Very simple. And then once done, you can issue command cluster.status, okay. Then you will see that you have a 3 node of InnoDB clusters. Okay. Then we need to create cluster set. We need to define a cluster set for this cluster. Then the command is very simple. Create cluster set. That's it. Then you will have one cluster set with one InnoDB clusters. Okay. As you see, one cluster set, one InnoDB clusters. The name of InnoDB cluster is BRU. Okay. Then we can add replica clusters. Okay. And then how to add? It's very simple. Cluster set.create replica cluster. Then you will have two InnoDB clusters. Okay. Additional InnoDB cluster has been added into the cluster set. Yeah. With one node, which is primary node. Yeah. On the replica cluster. After that, we can add instance to that primary node so that we will have second instance and third instance running on replica cluster. And you will have 3 node InnoDB clusters on primary cluster and 3 node InnoDB cluster on replica clusters. As you see over here, you can check with cluster set.status, cluster set.status, and you can see, okay, you will have, that you have the 2 clusters, InnoDB clusters, 1 primary, 1 replicas, and then, yeah, that's it. Then if you need more informations, then you can add extended column 1. Then you can have more informations in the output. Okay, this is the high availability scenario. I hope I still have time. Yes, I still have time, about 7 minutes. And we can change primary members in the primary cluster. Let's say you have node 1, node 2, node 3 in primary clusters. Node 1 become a primary nodes, and you want to run primary node on second node. You want to switch. Then, yeah, easy. The same as InnoDB cluster. You can just issue command set primary instance. The same thing with the replica clusters. Okay, you can just connect to the primary node, connect to the replica clusters, one of the nodes, and then you can run set primary instance. Okay, to switch over primary node from node 1 to node 2, for example. How about the replication? The replication will follow. If you set the primary instance to second node, then on the primary clusters, then the replica cluster will follow. The replications, okay, replication will change, not from the node 1 of the primary clusters, but from the node 2. Yeah. If the primary node of the primary cluster fail, it's the same, right? It's the same like you switch the primary from node 1 to node 2. It will be automatically failovers to the second node, and asynchronous replication will automatically adapt with the new changes. The same thing with the replica clusters. Okay, if the primary node of replica cluster is down, okay, the failovers to another nodes, then the replication will still be happening. Starting on the new nodes, new primary nodes of the replica clusters from the primary node of the primary clusters. And then we can switch roles. Okay, let's say you have requirements. Let's run our application on the other side. Okay, then we can just do set primary clusters. Then it will flip the cluster roles. Primary cluster become replicas. Replica clusters become primary clusters, as you see over here. So how about routers? Routers will always follow the primary clusters. So we don't need to change anything from the application side. Okay, this is the process. Basically, once we run set primary clusters, then the cluster roles will be flipped. Primary becomes secondary. Primary clusters become replica cluster, and replica cluster become primary clusters. if we have a data center crash or network partitions, then we have a command called force primary clusters, okay, to force the primary clusters, force the replica clusters on alternate site to become a primary clusters. But, okay, we don't, okay, since there are a lot of circumstances happening, okay, in this kind of scenario, so we are not, you know, we are thinking to not have like, you know, but it's up to you, actually, if you want to develop like custom so-called witness on the third site, let's say on the cloud, just to monitor primary cluster and replica clusters and do some sort of automatic failovers from primary to replicas. I think it's more towards really situational, how much data loss that you know you can take. Because anyway, if primary cluster is unavailable, okay, we don't know what is the status. Maybe some applications still writing into it. So potential data loss will still be there. Okay, so this is the process of emergency failover to another clusters. As you see, we can use a force primary clusters to set a primary, replica cluster to be a primary cluster, and set the existing primary cluster become invalidated status and so on. So this is a status, as you see over here. Okay, only when the cluster status is not okay, invalidated and unknown. Okay, the rest of the status we can do a switchover and emergency failovers. So this is the restrictions that we have. Okay, on InnoDB cluster set, it must be MySQL versions 8.0.27 and higher, and only works with single primary mode, one primary and multiple secondary, and asynchronous replication is supported, again, and submissing is not supported. Okay, thank you so much for listening my presentations, and thanks for the time. Yep, yes, please. Thank you. Okay, if I'm not mistaken, okay, let me give you the mic. Is that okay?
Okay, yeah, Alvin here. Okay, so what is the most difficult change management issue you can think of, and how would you execute that? Okay, so for example, an upgrade from one release to another, or maybe even a secondary node. You have a secondary node that is in this geographic location, and we move to another country, for example. All right, so that kind of scenario.
Thank you so much for the questions. Okay, very good questions. Change management, okay, is more towards operational, you know, kind of things. Okay, how the user or customers actually using InnoDB cluster set. I give you a scenario. For example, if the customer is using, let's say, standalone instance, how to convert this standalone instance into InnoDB cluster set, okay, across geographical locations, and then how to upgrade, how to do patching, and so on, right? Is that your questions? Yeah, yeah. Scenario, okay. Well, let's say, for example, we have 3-node InnoDB clusters on the, let's say, Singapore, and we have disaster recovery on Kuala Lumpur, let's say, and we want to create a InnoDB cluster set to link up this, InnoDB cluster in Singapore and replicate to InnoDB cluster set on KL, for example, right? And then we want to do upgrade, let's say. I'm sorry? Singapore to KL. Yep. Okay. The primary cluster in Singapore, the replica cluster in KL. Is that what you want? Okay. So let's say you want to do upgrade, right? Mm-hmm. Okay. Let's say, I'll give you an example. If we have, data center movement, let's say, okay, for secondary data center. I don't want to use KL data center anymore. I want to use Middle East, for example, right? Then it's pretty much simple process. Basically, we need to create a replica cluster on Middle East first. So we need to run 3 InnoDB clusters within the InnoDB cluster set. Okay. After this stabilize, we can just commission the InnoDB cluster on KL. Yeah. The same thing with upgrade. You need to upgrade the replicas clusters first, and then followed by the primary clusters. Thank you.
Uh, Hello everyone. Hope you had good tea. So for the next session, we'll be talking about running in-memory databases on Kubernetes using NDB operator. We have our speaker, Hernando Ucasno, who works as a master principal solution engineer in MySQL at Oracle. Over to you, sir.
Thank you so much. Okay, thanks for the time. Okay, in this topic, we will explain about NDB operators to deploy NDB clusters on the Kubernetes. As we know that NDB clusters is clustering a shared nothing architecture. It is based in memory, means that data will be stored in memory in distributed okay, in-memory data set, and then it is always on with 99.999% system high availability, super highly available, and also always consistent because all nodes in NDB clusters are read-write, different with InnoDB clusters that we just explained just now. In NDB clusters, every node are read-write and always consistent. And it's massive linear scales with in-memory extreme performance. And what you get by running your database in NDB clusters, first is performance. Read-write scalables, okay, because all nodes are read-write, then you can get more throughput by adding more nodes, read-write throughputs by adding more nodes. And then it is real-time in memory, okay, as we know that memory can give better response times than I/O to the disk. And super low guaranteed latency. So this NDB cluster is designed for super low latencies applications, mission criticals in terms of performance. And data will be automatically shut across the InnoDB clusters, NDB clusters nodes, okay? And it makes, partitions available by default in NDB clusters. And this is elastic. You can change, you can add nodes easily in NDB clusters. Secondly, you will have a consistency. It is always on, read-write scalables. Okay, there is no data to be like in a waiting stage. Okay, the moment data is committed and the data will be available on all nodes, and always consistent. In fact, this is ACID compliance. Okay, durability is provided by checkpoint. Yeah, there is a local checkpoint and global checkpoint to make sure that the data that reside on memory will be backed up to the disk. Third is NDB cluster support SQL and NoSQL, and it is highly available, completely super highly available. Yeah, with 99.999% system high availability, and I will show to you later on. Okay, this is the NDB cluster architectures. We have NDB clusters consist of multiple data nodes over here to store data in memory and completely consistent. And on top of that, we will, NDB cluster has, various options to connect to the NDB clusters data nodes below. So you can write your own code using Java or using C++, and execute NDB API to, query, read and write data on the NDB clusters. Or if you have, majority of the application is using SQL interface to communicate with database. So NDB cluster have SQL nodes, has SQL nodes, okay, where the application, SQL-based application can connect to the SQL node as if it is connected to the, normal MySQL. Yeah. When I say normal MySQL, means that normally MySQL is application just connect to the MySQL and then do a SQL query and so on. So NDB clusters general architecture consists of 3 different types of nodes. The first is management node. Okay, management node actually store the configuration data of all nodes basically. And it's controlling the cluster membership as well as acting as arbitrators, arbitrator if there is any network partitions that potentially causing split brains. So management node will help to mitigate that issue. So second type is data node. Okay, data node is running the NDB engines, okay, to store data completely in memory, unless you define 1 or 2 columns in the table to store data to the disk. But that's not something that usually people do. Okay, usually they store everything in data memory. And third is MySQL servers, so that the applications, okay, can connect to the SQL nodes, the SQL node, and if the application commit data transactions on the SQL nodes, then the data is actually stored in the data nodes. If the table objects, yeah, the tables itself use NDB storage engine. Sorry. Okay. So this is the architectures, okay, the archivability architecture. In this example, we have 4 MySQL servers, okay, all are read-write. There is no failovers, all those things, right? Like an InnoDB clusters. There is no failovers because all is read-write. An application can use MySQL routers or any load balancer that you like, okay, to spread the load across the MySQL servers over here. But this MySQL servers does not store data locally, but it is storing the data to the data nodes behind, and the data will be stored in memory. And we have 4 data nodes over here that split into multiple data node groups, which is node group 0 and node group 1. Okay, so minimally we can have 1 node groups, yeah, which is node group 0. But if we have data size more than data memory, then we need to distribute the data, okay, to the second node groups. If data grows, then we can have another data groups, and data will be sharded across. And within the node groups, we can have 1 to 4 replicas, yeah, and they are fully consistent. And we have 2 management nodes, yeah, we can have 2 management nodes, 1 primary and 1 standby management nodes, okay. How about if we have major outage on the NDB clusters? Since NDB clusters is fully redundant, then if we have a lot of nodes within the NDB clusters having problems or outage, then NDB cluster will keep up and running as long as the data is still complete. The full set of data will still be there. Let's say, for example, data nodes 2 and data node 3 having a problem, but the data node 1 and data node 4 still have a full set of data, then this installation, this architecture, NDB cluster is still up and running. Even though the management node is down completely, it's still up and running because the management node only used for, in this case, only used for starting up the NDB clusters nodes. Yeah. Once it is starting up, it will look for the management node to get parameters, okay, for these nodes to starting up. Otherwise, it will still up and running. Okay. So if our data is growing and 1 node group is not sufficient, then we can have another node group. Yeah. And data will be sharded across. Okay, back to the topics. Okay, today's topic is about running the NDB clusters on Kubernetes. Okay. Now modern application is developed using microservices, okay, running on cloud native, where the monolithic applications is, you know, we break the, monolithic application, we chop the monolithic application to become smaller and run these smaller applications, okay, as microservice running on top of cloud native platforms like Kubernetes. And REST API become norms used by the modern applications for microservices to communicate and interact with each other. So based on survey conducted by JetBrains, it is evident that microservice and REST gain popularity nowadays. And based on survey conducted by CNCF, okay, it shows that majority of the companies right now at least think or have, you know, cloud native environments in their organization itself, in their organizations. Okay, so based on CNCF survey, 82% of organizations deploy a massive cloud native environments running microservice on top of Kubernetes. So this is like, you know, high levels Kubernetes architecture. So basically Kubernetes has Kubernetes worker nodes and Kubernetes control planes. Basically control plane consists of multiple Kubernetes worker nodes. The work, sorry, master node, not worker node. I'm sorry. Yeah, So control plane consists of multiple Kubernetes master nodes. So in Kubernetes worker nodes, we can spin containers. Okay, containers cannot run by itself on top of Kubernetes, but it needs to run inside pods. Yeah, pods will give networks identities. Yeah, will give identity to the running container inside. Then MySQL itself, okay, can run as a containers within a pod. We can run single MySQL instance within a pod, or we can run multiple MySQL container in a single pod. Yeah, and each of the container will run only one MySQL instance. And we can run MySQL instance side by side with side containers inside the pods. So our MySQL operators for Kubernetes is using sidecar containers basically to maintain the clusters inside the pods, inside the Kubernetes. So NDB cluster is very suitable for running in Kubernetes because resiliencies, because NDB cluster is also shared nothing architecture. It can operate without centralized managements or any single point of failures. It's not available in NDB clusters. It is completely high available. Yeah. And scaling is very easy, and data is shared across the NDB data nodes. And it provides consistency as well. And standards, yeah, it should support query standards. So SQL node is basically like normal MySQL instance, yeah, normal MySQL instance with NDB storage engine support. So how to deploy NDB clusters on Kubernetes? So typically we have, in Kubernetes, we know that they have deployments, they have replica set, daemon set, stateful set, and so on. But you know, database is stateful applications. Yeah, you need to store database data on persistent storage. So the persistent storage is really critical in database. Therefore, the models to deploy database on Kubernetes is using a stateful set. So stateful set here in our MySQL operators is used to deploy NDB MTD, is a data node, multi-threaded data nodes. Yeah? And then NDB MGM, okay, this is management node of the NDB clusters, and MySQL D, okay, this is the SQL node of the NDB clusters. As you see over here, okay, we can create a stateful set consists of 3 nodes or 4 or more, okay, and then we can attach storage into it. How we attach the storage? It requires PV and PVC. PV means persistent volume. PVC means persistent volume claim. PV is like a Kubernetes resource. It's a Kubernetes resource to define the underlying storage so that it can be mounted. It can be seen from the from the resources within the Kubernetes clusters. And PVC or persistent volume claim is like is a definitions. Okay, the size. Yeah, need from the PV to be mounted inside the stateful set container. Yeah, stateful set pods. In the MySQL context, we know, right, the MySQL database has my.cnf. And inside that my.cnf, there is a parameter called data_dir. And data_dir is always pointing to the directory where database data file is stored, are stored. So normally, database data_dir is pointing to /var/lib/MySQL. Therefore, we need to mount this PVC into this /var/lib/MySQL inside the container, okay, that running within a pod. Yeah. So this is the basic to run MySQL database on Kubernetes. So in the context of NDB, okay, we have management node, we have data node, and we have SQL node. Pardon me about the wrong diagram over here. It is not deployment, it is stateful set. So 3 of them are stateful set. Okay, management node is deployed using stateful set, data node is deployed using stateful set, and deployment, MySQL node is also using stateful set. And we have CRD. Okay, once you have NDB operators running on your Kubernetes, then you have additional custom resource, right? Which is MySQL controllers, NDB controllers, and pickup restore controllers. And here it goes. And we have NDB management nodes, okay, running within a pod, management node container within a pod. And we also have sidecar containers that are running on the same pod. And the sidecar containers is to manage the management nodes as well as to protect the pods getting failing if the management node fails. So sidecar container is like protecting the pods for not, it's not failing, yeah, so that the management node management node pods will always be up and running. And management node will need to have a config map. So config map will be mapped into the management node container. We also have a pod for data nodes container. Okay, it has persistent volume claim and persistent volume because data nodes is a component in NDB clusters where data is stored. Okay, although it's stored in memory, but in the end of the day, we need to store this data on the disk. Okay, this is how to install NDB operators. Okay, if you have, Kubernetes clusters running, either using Minikube or Kubernetes ranchers or whatever it is. Okay, and then you can easily install NDB operators using two ways. Okay, we support Helm installations, and we support kubectl and YAML installations. I show you here is using, kubectl and YAML. Okay, very much. The installation is pretty much simple. So once the YAML is executed using kubectl, then we will have, the NDB operators running. Yeah, two pods are running. First is the NDB operator itself, and secondly is the webhook servers. Okay, to deal with various NDB clusters containers. Okay, this is a NDB cluster YAML with minimal configurations. Okay, how to deploy NDB clusters? Okay, in quick way. Yeah, in Kubernetes using very minimal configurations. Okay, so I created a sample with YAMLs. Okay, and we can run NDB clusters on custom namespace. Okay, in this demo that I show you, I create a new namespace called NDB clusters. Okay, and then on my sample.yamls, I mentioned that namespace that I use is NDB clusters. Then I can have spec something like redundancy level equal to 2. Okay, and the node count is 2. That means there will be one node group. 2 divided by 2 equal to 1. So one data node group consists of 2 data nodes, and MySQL node is also 2. All right. And since redundancy level is equal to 2, then management node is also 2. Using kubectl, we can deploy the NDB clusters. Okay, using these YAMLs. Okay, once it's executed, then Kubernetes will spin the NDB clusters, as you see over here. Okay, once done, then we will have 2 pods running management nodes, 2 pods running data nodes, and 2 pods running SQL nodes. And all are deployed as stateful set, as you see over here. Okay, 3 of them: management node, SQL nodes, and data nodes. Okay, then NDB operators is also create 3 kind of services for management node, MySQL nodes, and data nodes automatically. And we can check the status. Okay, once done, we can check the status by logging to any nodes. Okay, in this example, I'm logging to management nodes. Okay, using kubectl -n NDB clusters is my namespace, and then exec -it, and then the pod, yeah, which is management node, and then the command that I execute, which is ndb_ngm minus C connect to itself, yeah, and then minus E show. Then it will show all the NDB cluster node status over there. Okay, as you see over here, we have two NDB, we have two NDB data nodes, okay, with ID 3 and 4. We have two NDB management nodes with ID 1 and 2, and two SQL nodes with ID 148 and 149. So adding SQL node, quite simple. So we can just edit the YAML files from 2 to 4 and execute. Okay, the next moment we will have additional SQL nodes running. Yeah, very simple. So we can show the status after adding nodes using the same way. As you see over here, we have 4 SQL nodes, so additional 2 nodes, SQL nodes. So now, how to access the SQL node? First, we don't know the password. Actually, the NDB operator will create 2 secrets and save the password inside the secret. Okay. Then we need to use base64 minus D to decode. Okay, since the password is saved into secret as base64 encoding, so we need to decode that, and that one is the password. So I can log in to the one of the SQL node, and then using the password, and I can log into the SQL nodes. Okay, from there I can do a query, I can get the parameter, all those things using view or tables that reside on NDB info. And this one is a slide that I want to show to you that this is really active solutions, as you see over there. Okay, I can I log into MySQL node 1 and I create database, I create table, test.test with engine NDB. Don't forget, engine is always NDB in order to make the table itself reset on the data nodes. And then I insert 3 records, yeah, using MySQL D0. Then I query, okay, MySQL D0 and MySQL D1 both are showing 3 records. Now I'm inserting, okay, record number 4 and record number 5 using MySQL D1. Okay, then I query from MySQL D0, as you see over here. Okay, MySQL D0 also shows 5 records. That means this is really active. You can connect your application to any MySQL node. And this is the best practice. Okay, we need to make sure, we need to make use of pod affinity and anti-affinity. Okay, so keep database nodes apart across racks, and then avoid collocation of instance, sharing the same data, and so on. Okay, that's it. Short descriptions about the NDB clusters, deployment on Kubernetes. I hope you enjoyed that. Thank you so much for the time.
I hope you are. Can you hear me? Yes. Okay. Hello, everyone. I hope you all are enjoying our sessions here at Database Track. For our next session, we have Ivan who is joining us live from Taiwan. He's here remotely as well. He works as a MySQL Senior Solution Engineer Manager at Oracle. He will be talking about building space-aware applications with MySQL GIS. So over to our next speaker.
share MySQL GIS at FOSSASIA. MySQL GIS might not well known to everyone. GIS, the full name of GIS is Geographic Information System, which is a set of coordination systems with longitude and latitude to deal with information of the Earth's surface. Actually, GIS is not new to MySQL. We have been supported when we're still at 4.1. MySQL used its home-built developed code on MySQL engine to support GIS. But for the limitation of MySQL and some of the stability issue created by the homegrown code, it was not that popular while we were before 5.6. In the version of 5.7, GIS is implemented by Adobe Boost Geometry. And we support a group of standards like OGC, SQL, ML, PAS3. But with 5.7, we can only support Cartesian coordination system, which address only flat edge service. It is not related to, not 100% matching with the sphere shape of Earth. And with 8.0, we can support the geographic coordination system that can deal with the ellipse of the Earth, and we can precisely, we can do some pressure precisely, much preciser than we used to be. And we also support GeoJSON data format. In addition to that, we also support more than 5,000 SRS. The full name is the Special Reference System. And the GIS features are built in by default. We don't need to install extra plugins. By creating information schema ST Special Reference System, which is a table. Actually, it is a data dictionary view. You will know what SIS system are supported by the specific MySQL instance. And the most important is that we also can customize SIS. For example, if you want to create your own SIS from a standard coordination system, but you want to change its longitude and latitude position to accommodate the imported data, external imported data. The only thing you need to do is to create your own SIS from standard, based on standard SIS system, and import it into the system. So, what objects are come with GIS? First, we have some special data to support GIS, like polygon, streamline, point, geometric, etc. We can use them to represent various shapes objects of the map. The type can be used as a column type of the table. And in order to operate against the spatial data, we also add various spatial functions, which including functions that convert between spatial data and the various data format, like a text, blog. For example, stgeo from text can convert well-known text into a geometric data, spatial data. Well-known text is a kind of a syntax to specify the shape of the object, like a line, point, polygon, or multiple polygon. And we can use AS text to convert the geometric data to a text, so let us be able to understand the content of the data. Or interacted with the rest of the system, with the rest of part of the database. So it will allow you to import and export outside data between the database and outside data for the spatial data. And there are also functions to get the spatial data properties, such as ST length to know the length of a line string, and ST SID to figure out what SID is the spatial data using. And we also have function to operate against two spatial data, such as ST distance to know the distance of the point, ST overlaps to know if two polygon overlap with each other, something like that. In SIS specified which coordination system is used to the spatial data. And the different SIS will come up different result when we execute the same spatial function. For example, ST distance will return different distance value with a Cartesian SIS and the geometric SIS, which is considering the round shape of the surface of Earth surface, and but the Cartesian SIS only take all the map as a kind of a flat surface. Of course, same as the rest of the object, we can use index to accelerate the spatial operation. For spatial, to create a spatial index, actually, when you create a spatial index, actually it is it does not create a B-tree structure. It will create a R-tree structure. The R-tree structure is composed by the MBR, which is a minimum boundary rectangular, and each node contains an MBR. And by walk through the R-tree structure, it will help us to get much better performance than the full table scan. And some of the spatial function will apply the spatial index automatically, like ST intersects, ST overlaps, ST within, or even ST distance. With this example, it shows how to deal with spatial data without between the outside of the spatial data with the outside of spatial data. First, if you need to store the spatial data, you need to create a table with a spatial data type. Like this one, I created a table called city, and they use a location LOC column. The column type is a point, which is one of the spatial data to store the location of the city. And its SID is a standard one, which is the 4326. And then I insert the data into the table, like Toronto or San Francisco. And for the location column, I need to convert the well-known text into a point. So I use ST geometric form from text to convert the point. The point is specified the latitude and the longitude and its SID. If you didn't specify SID, by default, it will use the default one, which is same as this one, 4326. We might not need to manually insert the spatial data one by one. There are many ready-to-use GIS data sets and also programs to import spatial data into the database. They include the data set that created by government agencies such as the Homes Affairs, Transportation Department, or some of the GIS community also offers those spatial data set. Like the street map of each country can be downloaded from OSM. The full name is OpenStreetMap. In my demo, I also download the street map of the Singapore from OSM and use OTR to OGR, which is a freeware from GDAL. GDAL's full name is the Geospatial Data Abstraction Library, and it is available from Anaconda. So as this example shows, I can specify which shapefile is to import. This example, I specify the region census year 2010 SHP, which is a shapefile. And the target database is the localhost. By default, the port number is the 3368. And the username, and I use the root as a username, as a user account to do the import. And the target database, target schema is GISSC. And the engine is DB. Okay, let's do something real. So I show you a demo. I'm using myself share to let you I'm using myself share. Yeah, to show that what I have before the importing. Then I create a SG schema or SG database and use OGR to OGR import the shapefile into the SG database. The target database is at the localhost, use a root account password, and the shapefile is sg_admin1.shp, which was downloaded from OSM and it shows the administration, the first level administration district of Singapore. And after I did the loading, let's check what I get. So in the SG database, you can see that I have a new table called map, and let's check what the table of map has. It contains 5 rows. Each row represents a district, a district of Singapore, like West, Central, North. And let's check the structure of the map table. It shows that there's one geometric column called shape. Its SID is 4683, which is not standard one. Sometimes it causes problem for me. And there's also one special index add on top of the special column. Now let's check what the client side can see. First, I use the Myself Workbench to check the content of the map. And so I select the content from SG map table. It shows 5 columns there. And when I move to form editor, it shows the detail of the row. The shape column will display the map of the shape. I think this map should be for central district of Singapore. And there's a text attached, a text with the shape. It is a well-known text. It shows the contains multi-polygon, and the longitude and the altitude of each point, which compose the area. And when I move to GIS view panel, it shows a map of Singapore. Actually, it was composed by those 5 districts, which is occurred from the SG map table. And do some adjustment to make the map looking better. Okay. Now let's look the data with a different tool, which is a QGIS. QGIS is quite popular GIS tool. If I need to show the data show the GIS data, I need to specify the data. I need to create a layer and specify its data source. The data source is the database, and assign to MySQL. The table, now I need to figure out which table I want to use. Actually, I picked the ST-admin1 GIS table to display. And add a layer, click the add button, then add a layer. It will digest some information from the database and let me be able to add what kind of content I'm going to add to the layer. So the ST-admin table should be displayed, and it shows the full Singapore map, which was composed by those 5 columns, which are all by district. And then I create another layer. The layer is shows the building, the location of the building. The buildings should be the buildings are from Singapore and Malaysia. And I also specify the table name as the buildings. And after I click the add button, it will show the location of each building. Actually, the building table contains almost 1 million rows, which is 1 million buildings between Singapore and Malaysia. So next, I will do some kind of operation with the manually with the ST function. In this demo, I try to show you which building are located within, within 1 kilometers away, less than 1 kilometer away from this building, which is a lifelong learning center. The first thing I need to know the position, the location of the lifelong learning center. So I create a column called point 1. It is the data type is the point. The point shows the location of each building, and after I create it, I insert it into a local variable called SIPNT. And after I did the query, the SIPNT contains the position of the lifelong learning center. Then the next selection is I query against the building table and use a function called ST distance field. The input parameter is the point 1 of each row, and the local variable SI point, which is the location of lifelong learning. Use the ST distance field to know the distance of each building between the lifelong learning center, which is videos of the FOSSASIA. And also at one phase, the type should be commercial. So it shows the commercial building that which distance is less than 1 kilometer away from this place. And then it shows the distance here. So the result shows that there are 4 buildings are less than 1 meters away, and their distance are about 900 meters, about 900 meters from the vineyards. Yeah. The last part is the key takeaway. This is Mansell 8 implements so many GIS features, so comprehensive GIS feature, and it follows standards, follow most of the standard like SQL, MM, or OGC, and it can also support multiple SIS, and you can also customize your own SIS. And with the index, with a special index, it will facilitate the query performance or the operation, spatial operation of the spatial data. And because it follows standard, so most of the GIS tools supported by SQL include third-party tool or our own tool like Mansell Workbench. And so GIS is totally be able to support most of the GIS information system or GIS applications. So you are free to use the GIS feature from MySQL because it is included in the library by default. You don't need to pay any money in order to use the MySQL GIS. And on the other side, it also let us be able to extend our existing MySQL application to add some location-based feature to those applications. So please feel free to try the GIS feature of MySQL and let us know your comments or your suggestion against those features, and either contact us directly, send an email to Ryan or to Hernando, or you can log a bug report with in our bug reporting system. Actually, it's not limited to bug. If there's a feature enhancement required, you can also use bug report to show your requirements with the MySQL developer team. Okay, that's all from me. Thank you very much.
Hello everyone. I hope you are doing a good job. So, like, we have our last track in our before our afternoon break. Um, for that, in our database track, we have Oleg from Russia. He's going to talk about YDB, which is an open source distributed SQL database. Over to you.
Thank you. Thank you for having us here and for warm and welcoming atmosphere. Let me introduce you to yet another database because Y stands exactly for yet another. No, I cannot. I need type C. Please give us just a minute. thank you for patience. Just minor technical issues, but we overcome it. YDB is an open source distributed SQL database, and its main characteristics include that it's, first of all, it's relational database, so we provide AC transactions support, SQL Direct, our own extension for ANSI SQL, we call it YQL, yet another query language. It's strong, consistent database, so from CAP theorem point of view, it's CP. In case of partitioning, we tend to be consistent database. And we provide serializable transaction isolation level. We can scale up and scale down from few servers up to thousands of servers, and in production, our main clusters consists of thousands of servers. Our biggest installation consists of more than 3,000 of servers. This is a highly available database, so we created it in order to run in multiple data centers, or you can call this available zones. It's fully automatic, so under one of availability zone or data center downtime, it survives and it continue be available for both reads and writes without any intervention. And after your data center is up, everything still working and your programmers don't see any problems on their side. So the system is fully, automatic. Okay, it's mission critical database, so it works in projects with 24/7 uptime requirements, and we provide running restarts and running upgrades, changing of hardware or everything without any downtime. And we created this not only as a relational database, but as a data platform, provided ability to create tables, persistent queue topics, distributed queries, and even analytics. It's 100% open source software, built from scratch almost 10 years ago, built on C++. And 1 year ago, we published our source code under the Apache 2.0 license. The whole platform, SDKs, documentation, everything is available under Apache 2.0. Please join us on GitHub. You can see URL on the screen, or you can use the QR code. From physical architecture point of view, it's shared nothing architecture, and we tend to use only commodity hardware, so no any vendor lock-in on any storages or any computers. You can buy any available server, any available CPU, memory, etc., and build your own cluster. Compute and storage layers are separated into two parts, so you can easily grow and shrink every of them independently. For example, let's say you have millions of transactions per second and only megabytes of data, or you can have petabytes of data and single transactions per second, and you can grow each layer for your workload. Main primitive of the system, one of the main primitives is a table. Tables have primary keys and data within this primary key ordered. So you can easily make lookups to this table, and the main point is that you can grow up your data in the table almost infinitely, from kilobytes to petabytes, without any intervention from programmers, from your DBA, etc. Tables are automatically partitioned by primary key range. So we gather statistics about your workload, about your reads and writes, and depending on it, we can split it automatically. Based on statistics collected, we can split table by road, by your data amount, or by your read or write throughput. And system itself tends to put all those table charts through the whole nodes evenly by the whole cluster. Our dialect has some extensions to ANSI. It's strong typing with named subqueries. So we have a lot of built-in functions for any cases like for daytime, math, JSON, Unicode, etc. And you can find very familiar constructions in DML and DDL, so everything will be very familiar for anyone. Main features of the system is secondary indexes. We have synchronous, asynchronous covering indexes. We have special time to leave indexes. Automatically deletes your data after it's expired. We have table compressions and backup and restore from S3. I will continue with the features. It's encryption at rest and in transit. We have read replicas in case you want to increase your read throughput. Special change architecture in order you want to keep track of your data changes within the tables. Special JSON API with text JSON and binary JSON representation and functions to work with it. And special analytical scan queries in case you want to deal with your data without any problem with your OLTP workload simultaneously. From a programmer's point of view, our application team creates, as far as we have gRPC API, public gRPC API, our application team creates SDK for many for most popular languages. You can see them on the screen. In case you want to deal with a database in a convenient way, we provide user interface included a lot of useful features like DB Navigator, like execution, explain plans, diagnostics, etc. And in case you want to deal with database through CLI or use it in, I don't know, any scripting language, you can use our CLI that completely covers all our API functions. We provide a lot of functionality for observability of your database, and we support mostly popular Prometheus format. We provide in our GitHub repository Grafana dashboards for database. And with every cluster, with every binary, we have embedded user interface and special system tables for a representation of statistics and analytics of your workloads here. So you can observe your tables partitions, your queries like slow queries, heavy queries, etc. You can easily deploy YDB with our Kubernetes operator, or, for example, use our Minikube for development and testing purposes. You can use it in virtual machines or just run it in bare metal using binaries or compile it yourself. Or at least use Docker container for development and testing purposes. And I'm almost done. Yeah. And I just wanted to say that it's still a work in progress. So it's quite a mature product. We started our development almost 10 years ago, but we are on the way of continuous improvements. And as we saw a lot of our clients request to be more compatible with most popular databases, we work on PostgreSQL compatibility. So now currently we almost completed support of PostgreSQL dialect syntaxes. We completed support of PostgreSQL data types, almost all embedded functions via protocol, and we tend to be compatible with PostgreSQL. Moreover, we tend to be, and our aim is to be a so-called H-step system. So both system for simultaneously for OLTP workloads and analytical workloads without any intervention between them. So we work on our columnar store. So when I thought about tables, I thought about role-based store. So now we are in progress with columnar store for analytical tables. We work on data tuning, so we can cool down your data to most cheapest disks like spinning ones, or you can cool down your data, your mostly like useless data to S3, for example. So it's one of the cheapest ways to store your data. And all this stuff will be invisible for end users. So you can have one table, and the table will store based on the tuning. It will stores all the data on different storages, but you can within one query just make a query like select asterisk from table with any filters, etc. Moreover, we work on streaming analytics on those analytical tables, and that's it. Thank you again. Please join us on GitHub, visit our website. You can find there all documentation or our materials. So we will be very grateful if you join our community. Thanks again. Thank you for having us.
We're open for Q&A. Sure. So do any of you have any questions?
Hi, so I just want to ask, right? So you have your own query language, YQL. So I understand that most other databases, when they have their own query language, is because they can't fully support SQL natively, like all types of queries. So is there anything that SQL can do, but YQL cannot?
We tend to be compatible with, as I mentioned before, we tend to be compatible with PostgreSQL, so we tend to cover almost all the SQL features. And we created it because it's a dialect both for our OLTP system and moreover for MapReduce system. So we try to cover the many stuff, not only for OLTP workloads, but for analytics, for MapReduce, etc.
I think, okay, you have one more question.
So please welcome everyone.
Can you hear me? Oh, right. Hello everyone. Thanks for joining the Korea's Open Community session. We are from 4 different communities. Can you see me? Yeah. So including Cloud Bandwagon, Women Code Seoul, C++ Korea, and Women's Korea community. And we have only 20 minutes, and we are going to talk about all our communities. So time is running out. So let's hurry. So first of all, I'm Justin from Cloud Bandwagon. So I'm going to talk about what we are doing and why we started this community on behalf of the cloud community. So let's think about this number. Can you guess what this number is about? 52 million. Yeah? Right. So I will add another number, 26 million. So can you guess this time? That's correct. So this is the total population in South Korea. And surprisingly, the half of this population live in Seoul metropolitan area. I don't think this is a good idea because the rest of the land are utilized inefficiently. So this is an infographic which has become the popular last year, and which is about 9 ways to see South Korea. And I got my eyes caught in the 6th one, which is this one. So this is how Seoul people sees the whole country. And as you can see at the bottom, this is the Jeju Island, which is known as Tangerine. And that's the blue one is the Busan, which is known as beach. And can you see the red one? This is Incheon, which is known as airport. And the yellow one is Gangnam Province, which is known as potato. And the other place is just simply as none. That's how Seoul people see the whole country. And I live in the area of none. So, what does this mean? This actually has a sort of serious issue in terms of the information flow. So it has resulted in the information only stays in Seoul. So as a result, we've seen this kind of social phenomenon called digital divide or digital extremization. So it's not good at all. So all the information should be transparent and accessible from everybody. Therefore, we started this Cloud Bandwagon community to let the information flow out of Seoul. But how can we do this? We cannot do this by ourselves solely. So we need to make alliance with developer communities in the regional area, as well as student communities, right? And we have these 6 people within this Cloud Bandwagon communities. And 3 of us are working as a developer, which is developer relations, and the other 3 is industry experts, specializing in like cloud infrastructure or programming language or AI or machine learning. So, as the Cloud Bandwagon activities, we focus on these 3 categories because these are demands from the local and regional developer communities. First is cloud technologies, and second is open source technologies, and the last one is career development. So, what we have done so far, we have run several of the sessions, and this is the first one, which was in May last year, and we got the 20 people. This is the beginning, and we ran another one in July in Daegu, and this time we collaborated with GDG Daegu. And this is the one, another one in Jinju, November last year. This time we work with Gyeongsang National University. And this is the latest one. And this time again in Daegu. But this time we work with local council. And as a result, we got a lot of attention from the local communities. So we just started this community. And it seems to be, we are growing. But I think this is illusional because we need to think about how we can make sustainability. And we still need to long way to go. So how can you do this? Please keep an eye on it. And we need your support, we need your attention, right? So please stay tuned at Cloud, right? And we will be able to see share a lot of information. Also, we can open to expand to across the whole Asian region. Thanks for listening. I will hand over to Yeonjung from Umano Code Seoul.
Thank you, Justin, for amazing introduction. Hello, everyone. I'm Yeon Jung, AI lead from the Women in Code Seoul. Yeah, before I get started, I would like to introduce about Women in Code, which is the largest and most active community for technical women in the world. So, Women in Code is an international non-profit organization founded in 2011 to inspire and empower women in technology. So our mission is empowering diverse women to excel in their technology careers. And we aim to make a tech industry where diverse women and excluded people thrive at every level. Women in Code started as a small community group in San Francisco and quickly expanded around the world. As a result, we now have a strong and expanding global network with 320,000 members across 147 countries all around the world. And in South Korea, we have a Seoul network, which is one of the most active. So I'm going to introduce about Women in Code Seoul. We launched it in May 2019, and currently we are one of the fast growing and leading women tech community in South Korea. Now I'm going to share what we did for the last few months. So first of all, FOSSASIA. We collaborate as a community members, a community partner with FOSSASIA and delivers 5-minute talk and online gathering in the last year. And NAID IT. We are providing information about different tech roles by interviewing with women from a range of positions. And next, content productions. We have been creating insight-first content such as DEI, which is diversity, equality, and inclusion, and some other technology information such as Spring Framework, NFT, and more. So next, translations. We translated Women in Code's official blog from English to Korean so that in order to provide Korean tech speakers with easy access to valuable content. And Women in Code Seoul big event. We had a variety of interactive workshops and networking sessions that enables women in tech to connect, learn, and grow together. And next, collaboration with Samsung. Our leaders share insight stories such as their career journey, community stories, or deep tech, And we have a networking session together with the different community in South Korea. Last but not least, mentoring session. Our leaders share their experience on front end and AI to support and empower next generations of tech professionals. So yeah, still we are trying our best to inspire more women in tech in South Korea. And in this year, 2023, we plan to organize more accessible programs to support more women in tech and focus on the global movements to empower leaders across the industry. So please stay connected if you are interested in collaborating with us or reaching out to us to support more women in tech together. So you can connect us through our official email, womenicalsoul@gmail.com. So yeah, keep turning your eyes on and yeah, support us. Thank you for listening, and I'm gonna turn over to Dunga.
Greetings, folks. I'm Park Dong from South Korea. Let's start my part. Okay, here is there's a frequent questions we receive. Why you started this community? Honestly, C++ programming language is quite hard to study, and it has multiple standards from ISO community. Literally various solutions in runtime environments. And each has some type of specific APIs. For instance, in Apple platform, you have to run the Xcode. In Windows, you can run Visual Studio, and in Linux, you can sort of combine multiple tool chains. And most of all, the language is one of the oldest, which means the spectrum of the C++ users is really broad. You may have heard about the book series, Teach Yourself Something in 21 Days. This humorous cartoon describes how it actually works. Beginner will learn this language in 21 days and start the person's career for 2 years. And professional developer will use this language for about 10 years, multiple projects, and learn from their colleagues. At some point, you suddenly start learning physics and quantum gravity for another 10 years. And next, spend another 20 years to learn biochemistry, genetics, for another genetics. Finally, you go back to 21st day and replace yourself. What a story, isn't it? So therefore, we are maintaining a place for people who want to make detailed questions and discussions in their mother tongue, I mean, a Korean language. We started in Facebook in 2013 because it was an easy platform to create community. For years, we posted questions, discussed it in comments. Of course, Korean C++ users use stable flow or there is a simply less section. After the foundation, we focused on archiving some useful learning materials, especially for beginners. Seminar, translation, and readings together. After the pandemic, we wrote our code of conduct for online activity. Sometimes open the study group in video call. Currently, we are moving back to offline, organizing some small meetups every 2 months, planning to open one-day technical seminar, and sometimes YouTube video creation. Okay, finally, this is our recent concerns. Our first goal is to found a non-profit corporation. We need to gather some sponsors, and we have to have a duty to provide some clear financial reports about it. The second reason is making ease of compliance with companies. There are some long stories about this. If you are curious about it, you can visit our booth and share some knowledge with me. Okay. And the next one is for better communication. We are trying Discord to support more instant chat-based discussions or questions rather than Facebook. Okay, thanks for listening. This is the end. Next is Ubuntu Korea community. I will forward this remote control to Yongbin. Thank you.
Oh, thank you, Joma, for the introduction. So, my name is Yongbin, and I'm going to talk about the Ubuntu Korea community that I'm involved as organizers. So there are many local Ubuntu communities around the world, and we're one of them based in South Korea. And we started our community in 2005. And we usually organize some local Ubuntu meetups and activities to promote Ubuntu Linux and related open source in South Korea. So we're usually active on both online and in person. For online, we have our own online forum where people can ask some Ubuntu questions like Ubuntu not compatible with my data, or when someone deliver some answers, meet you, something like that. Group chat also available. Like we have IoT and metrics, and we also have our own wiki for documenting some specific case studies for the Korean users. For in-person activities, we organize seminars where people can share their experience around Ubuntu and workshop to have some newcomers to get used to Ubuntu. Since the Ubuntu itself is a platform used by a wide range of users, we also frequently collaborate with other host communities in South Korea for some joint events. Through the Ubuntu Asia and Ubuntu Summit, we also exchange with other local Ubuntu communities such as Ubuntu Japan, Taiwan, Malaysia, and much more to share and learn how they use or contribute to Ubuntu. We are mostly people of Ubuntu users, but we also encourage people to contribute to Ubuntu projects by participating in localizations or recording faults, which is important to improve usability for the Korean users. For past few years, we've been putting many efforts on Ubuntu Asia, which is started in 2021, and to make a place for gathering Ubuntu users and contributors for many countries in Asia. Ubuntu local community in Asia is actually not much active compared to other regions. Even if it will be active, it was quite difficult to reach out. But with some success from our first two events, we're now seeing many local communities getting back slowly. I think Indonesia community would be a good example, as they're trying to reserve their community by organizing Ubuntu Asia in Jakarta, Indonesia, this October. There are many large gatherings for Ubuntu Talk, such as Ubuntu Summit, which was formerly Ubuntu Developer Summit, and there are also other many UbuCons in the other continent, like UbuCon at Scale, UbuCon Europe, Latin America, and Korean community is also thinking about organizing UbuCon Korea this year. While we have been focusing on global activities by this year, we're now trying to put more focus on local activities this year. Starting from revamping our online forum using Discord, and supporting Dragon Developer Day, which was organized by Cloud Bandwagon earlier this year. We plan to start organize our periodic seminars and translation workshop again to gather people in person. And we also continue to revamp our online services like our wiki and our online chat, which is outdated a bit or need some new approach. As I mentioned, UbuCon Korea is also planned. And also, if you got any details on UbuCon Asia or Ubuntu Summit this year, we also plan to participate and exchange with other Ubuntu folks.
So that's for the road to Korea. And if you would like to learn more about us, you can feel free to visit our website or contact us via email. So that's all for the Korean Open Community session. If you would like to learn more about us, you can scan the QR code right here, or we have our booth right there on your back. Kain, would you like to raise your hand? Yeah, there is. You can see that. Feel free to visit our booth and ask some questions about us, so that you can learn more about us. So, thank you for joining our session. See you around or see you at the booth. Thank you for joining.
Thank you very much, Young Bin, for your talk and everyone. So I hope you guys all enjoy the talk and also enjoy the lunch as well. So very soon, in about 10 minutes, we're gonna have some learning talk. So please stay put. Thank you.
나중에 유튜브 올리실 거죠? 로봇 코리아에.
앉아가지고
Here or here?
plugs into hundreds of different community and corporate provided plugins to let you query on basically anything. We have dozens of different visualization panels available, plugins where end users can create their own. And Grafana Loki is an open source logging database that can run from very small deployments to very, very large ones, ingesting terabytes of data a second. It's got a great simple query language that we'll show off in a minute, and it's got really efficient data management. You don't end up with indexes twice the size of your ingested data, so the storage costs can be very, very reasonable with a database like this. So we see a lot of open source deployments of both of these together, and I thought I'd show that off a little bit. This is one of our public dashboards that are available at play.grafana.com, which is a way of showing off, what the tool's capable of. And this is a dashboard that's entirely built out of Nginx access logs. We take the sort of standard Nginx access log format and produce, paneled out request rates and their various statuses, all things you might expect. We can produce global visualizations. We have a great, global map panel that's available based on OpenStreetMap tiles and a bunch of other different sort of request statistics. So I thought I would show a couple queries and how those are built. So, all of your logs look like this, just a giant string of text, timestamps, whatever random thing that your end user puts in, and then all sort of in the standard, Nginx log output format. And we can do some really great simple queries inside Loki to turn that into useful numbers. This just says, as I stand in front of it, sum by the host name counted over the time interval that I'm graphing. Like you write that short, simple query, just give me everything by host. You can write a query that's a little bit more complicated, filters out everything that's a Google bot, divides it by everything that's not a Google bot, and gives you a percentage of your requests that are coming from Google. Again, this really small one-liner query that can run efficiently over the last 24 hours. Let's see how long we can go. Let's go over this last year. That fast, right? We can run a pretty big query over months and weeks of data that quick. And then we can do some cool visualization stuff based on this. We can specify what our log pattern looks like. This is that pretty standard Nginx log pattern, give everything names like a method, and then count it and sum it by the country code. And then our map visualization tool gets a look at that table, right? It's like country code number. And it can draw these nice circles in each country based on those codes. And it can do, ranking based on that same query. Well, rank me the top 10 paths. You can get all of this in a pretty full-featured, nice open source tool connected right directly to another open source tool. We love to see sort of complex deployments of that. And I thought I'd show off one more thing about how powerful Grafana is while we're here. This is all a Grafana dashboard, the little Doom data source running at a very respectable 5 frames per second. So that's all just sort of running locally in our browser. All of those data sources are hooked up together in a sort of in-memory thing in the back end. Cool. Thanks for your time. We're right over here if you want to talk about any of our other open source observability databases too.
Thank you, Joe, and please welcome Jean from the IO Foundation. Thank you.
Hi everyone. All right, so my name is FOSSASIA. You can call me John. I'm here on behalf of an organization called the IO Foundation. We are a tech NGO advocating for data-centric digital rights. And that's something that I wanted to discuss with you. There's probably one is on over there. There you go. So I want to talk to you about this framework we've been designing in the past couple of years, more or less. It can be a little bit different than you may have seen on this kind of talks. So the idea is try to follow up this, okay? This is probably one of the nicest nerd jokes I've ever seen in my life. And the idea is that you guys are building and implementing and architecting all the software, all the technology that everyone is so much concerned about. And so the question is, how this had this conversation with someone not too long ago. Well, you would like to have a career building software that is going to be nice to people and that's going to be not harming them, correct? Show of hands, who's a developer here? Okay, so for the most part, you would like not to build, not to deploy packages that are going to be harming people, correct? Show of hands. Okay, cool. So the idea is, how the hell do you measure that? Not in a conceptual term, but how you actually can have a systematic way of assessing that. And that's really the problem. There's no algorithmic approach to try to answer that question. And that's what we've been trying to work into. Because among other things, what it gives is a sense of purpose on how you're going to be deploying, how you're going to be designing, how you're going to be architecting. In other words, in our organization, we regard developers as the next generation of rights defenders. You would want and you would love that if a piece of software is deployed in a specific jurisdiction, and that jurisdiction has a number of protections to the citizens, that those regulations are embedded into the technology itself. In other words, you leave the complexities to the experts and you just allow people to just be users. A good example of it would be, say, GDPR, for instance. It does provide a number of protections in terms of data protection for the user, but as things stand right now, everything is very active. What I have is the right as a French citizen. If I discover that Meta did not delete my data on my request, then I have the opportunity to go and sue them. That takes way too many presuppositions about me knowing that they have actually not deleted the piece of data or they haven't complied with my request. And then it also presumes that I'm going to have the money and the time, the resources to go and sue them, which is absolutely stupid. It's not going to happen. In a properly regulated industry, any single company only competes at value proposition level because compliance is the bare minimum for you to be in the market. In the software industry, that doesn't happen. You compete at both value proposition, but also at compliance level. That's a huge hindrance. So if you want to be able to have programmers who are going to be the ones designing and implementing software that is going to be protected by design, you first have to give them a sense of purpose. And the only way to actually achieve that is to provide them with an algorithmic approach on how they have to do that. So we've been trying to find a gap in how to explain things such as human rights and so forth from a tech perspective. So we do have a narrative. I cannot get into details right now. We also find a way to explain what's the difference between human rights and data-centric digital rights. Again, too long to explain in a very 5-minute short lightning talk, but we do have a way to explain this. And so we came with a concept of a data-centric digital right framework that has a number of components upon which we are working. One of the most notable ones is those 3 principles to guide what is the design of the framework. And the first one is I am my data. Think about it as treat somebody else's data the way you would like to be treated. It's a very simple way to think about it. It already changes the way you are perceiving everybody else's data. Principle number 2 is end remedy. We tend to have regulations right now that are very remedial in the way they are done. So again, I can go and sue Meta if they don't delete my data. The idea would be is that that never happens. You want to call so that the situation or the problem never happens to begin with. That's actually a change of mentality. And the third one is rights by design. If you have a specific regulation that provides certain very specifically defined rights to a user, those should be implemented in the technology directly, transparently for the user. I don't concern myself as to how the ABS or the airbag system functions in a car. That's not my business. The car goes through a number of verifications as a prototype before it gets into the market. And my responsibility is not to be an idiot when I'm driving the car as a user. So, it's not my problem how WhatsApp protects or not protect my data. The idea is that I shouldn't be spreading idiot, stupid things around WhatsApp. That's my responsibility as a user of the platform. And right now, all of that is very blurred. There's no distinction between the two of them. Part of the main work is what we are doing on establishing a very specific taxonomy on digital harms and digital rights, and this is from the data perspective. And something that is still very, very surprising to me, there's no international consensus on data use cases, and that creates all sorts of problems, and we're also trying to work on this. So we've been having working groups on this topic. We are currently having research on 2 of the areas, and we hope to be able to release some type of MVP by the end of the year. If anyone is interested, you can find us at our booth over there on the corner or send me an email. Thank you so much.
Thank you very much, Ron, and please welcome Benny.
Maybe. Ooh, there we go. So I am here, my name is Benny. I am here representing an organization called the Linux OS Foundation. If you are familiar with the Red Hat ecosystem at all, then you have heard that Red Hat has decided to discontinue the downstream version of CentOS. If you have ever used CentOS, specifically 8 or 7, in the last 5 or 6 years, you're going to end up having to migrate somewhere else. As users of CentOS, we love the Red Hat ecosystem, and we still needed downstream Red Hat for free, so we decided to start producing it. We set up a foundation, a nonprofit that is incorporated in the US, And that foundation owns all of the intellectual property. It's controlled by the community. It's staffed by the community. We are all involved in the Red Hat ecosystem because we care about it. And we are working very hard to provide Red Hat for free to replace all of the people who, or to offer a replacement for people who have historically used CentOS, but that want to stay with Red Hat in the ecosystem. But we also are fixing the pains that we had as CentOS users. So if you ever experienced the delay in releases for CentOS, we're now releasing one day after Red Hat. We have worked with the Red Hat ecosystem community to create a project called Elevate that allows you to upgrade and migrate between Red Hat flavors in place. If you've ever had to migrate your CentOS system, you have had that pain point, and we have worked to fix that. Individuals can join the foundation for free because we want people to have a voice in the future of Linux if you care about the future of Linux. I'm over against the wall over there next to Debian. If you want to come say hi, I'll be here all the rest of the week. And I have a talk tomorrow about open source that you can come see at 2:30. Thanks so much.
Thank you, Benny, and please welcome Brandon. He's going to talk about Lightweight Express VPN. Thank you, Brandon.
Thank you. Hello, everyone. I'm Brendan from ExpressVPN, and I want to talk to you about two things today. First one being Trusted Server. You might have heard of it on the internet. I helped co-create that, and it's a privacy-centric operating system developed at ExpressVPN. And it heavily respects users' privacy and helps us ensure that we can prove to our users that we're keeping you safe online through verification and audits that have been done by third-party companies. It's been extensively audited multiple times, and we know it's secure and it's cryptographically proven through things like reproducibility and immutable builds. The second thing I'd like to talk to you about to try and link these two concepts back together is Lightweight. Lightweight is our internal VPN protocol. It's completely open source. It's trying to respect people's privacies and freedoms for the internet, but more so, it's a way of ExpressVPN starting to give back to the community, starting to think about how we can offer new technologies to help individuals, other firms, and other organizations, even nonprofits, that need to secure their communications on the internet at all times. Lightweight has been also audited extensively, I think twice, and we're quite confident of its capabilities and what it's going to provide in the future. There'll also be a talk tomorrow by Peter Membry about Lightweight and why we developed it. I'm guessing most of you will have questions around, well, why didn't we just use WireGuard, or what's wrong with OpenVPN and things like that. That talk will address that, but more so, it's just an interesting concept of how we developed it and why we developed it. So I'd encourage you to come along and have a bit of a chat with Pete afterwards, or have a bit of a listen about what we got to say and how we're trying to be better community members in the open source environment and promote transparency, promote sharing this information with you guys and proving to us and you guys and everyone else here that we actually are respecting privacy, not logging things, doing the right thing, and trying to be good open source community members. If you want to know more about Trusted Server, please come find me. I do stand out a little bit, but our booth is just over here, and we can talk about Trusted Server all day. I can talk about how that's secured. There's no open source component for that yet, but it's based on Debian, and we use all upstream tooling, so I can freely talk about that. And of course, Peter Membry can talk about Lightweight. Any questions, please come and find us. Anything you want to know about why we're trying to be better community members and what we're trying to prove and show, again, please come find us. We've got nothing that we don't want to talk to you about here. We want to be more open and transparent with everyone in the community. Thank you.
Thank you so much, Brendan, and please welcome Shahan on stage. He's going to talk about the art of image processing using Image Lab. Thank you very much.
Hello everyone, I am Sahan from Emanator at the Schoolabs. So I just want to give a shout out for one of our major products in Schoolabs, which is Image Lab. One of the main tools, even a child can learn about image processing. So I just want to give you the intuition and what the current features and the future work of our product. So about Image Lab, it's kind of an image processing tool, which is a standalone, and it's an active open source project at our Sustainable Computing Research Lab at our Schoolabs. So it's licensed under Apache 2.0, and it's currently appeared in Google Summer of Code, starting from 2020, and currently in this year as well. So what is Image Lab? It's a standalone tool, as I said, motivates anyone to get started with image processing, presented in an interactive and very less code way. So it's a rapid and real-time environment before you're doing actual implementation, even comes to image processing, anything you are doing with image processing. So why Image Lab? There are currently available tons of applications and other products when it comes to image processing. So the existing methods are not beginner friendly actually, even for the child and undergraduates, for all the students. And it's a scripting used, as you know, by using Python. It's kind of a hectic situation for the students, and there is no flow of learning. So that's basically what happens next. So how to use Image Lab? So can you imagine it's just 2 steps. As the first step, you just have a rough of sketch about your work, kind of a pipeline. So as an example, I delivered it here. Just you want to read an image and scale it, kind of pre-processing steps, and you just want to do finding contours in your image. So basically, this is kind of an abstract wave where you have to drag and drop all of the things, and you just want to do some sort of image processing or pre-processing steps. And yeah, there you go. You can do anything by using Image Lab. And it supports various kind of image processing tasks, starting from image I/O and conversation smoothing, filtering, drawing, thresholding, geometric transformation, even image processing, object detection. As you saw in the last image, it's kind of a messy UI, and we improve it by using Scratch, which inspired by MIT research, and more interactive and beginner-friendly way. So basically, now the current progress is on here with OpenCV.js and Electron.js. Yep, we also provided fully documentation for all the developer guide with the application guide, all for the users. And this is the technologies. And yeah. About the future work, we are hoping to integrate deep neural networks by using Caffe and TensorFlow, DNA models, and also multiple image processing and parallel processing as well, and web integration and video analysis as well. Yep, yeah, this is kind of our vision to transform Image Lab to must-have image processing tool to every educational institute. Yeah, please enjoy. This is kind of our current state of our application, implemented based on Blocky.js and Electron.js. So, yeah. Thanks a lot.
Thank you, Shahan. And sorry, our sessions are resuming.
You need to switch off one. Sorry. Okay, so I'm sorry about this. We have the 2 microphones together. Hope you guys can still hear me. Can you? Yes? Yeah? Thumbs up? Okay, so you survived this, yeah? Okay, excellent. So thank you, Bella, for doing this, yeah? And it's a lightning talk, so we do it tomorrow, yeah? At lunchtime? Or a little bit later? Because now the people are already heading out, and I see like a lot of people already heading out. The sessions are starting, and we have a short break here on the stage. So again, sorry for this loud noise here, right? We still all have to get used to the post-corona crowds and noise, right? Yeah, and have a good time. So now what we have is the hardware track. For example, a lot of people wanted to go to the hardware track. We have the database track continues with a lot of cool talks about MySQL. Postgres, there's also like somebody talking about MongoDB. I mean, they chose another license, right? So maybe we can discuss about that. And yeah, what else is going on? What other tracks do we have today?
Thank you.